Lesson 5-2, solving equations with variables on each side. It's taking the equations we did in the last chapter and adding another step, just moving more towards multi-step equations. So the first thing that we're going to do is we're going to bring variables together on one side. So what you do is you look for the smallest number with a variable, and you add or subtract to take it to the other side. That's kind of the thing you're going to look for, the smallest of the two, and add or subtract to bring it to the other side. Remember, whatever you do on one side of an equal sign, you got to do on the other. Once you get the variables together so that there's only one, then you should be back to a normal two-step equation. You'll take the constant, the number without a variable, to the other side away from the variable, and then divide. So just adding one more step to our two-step equations from last week. So let's try this. Example 1. 7x plus 3 equals 2x plus 23. So if I look at my two variables, I've got 7x on the left and 2x on the right. Remember, I want to take the smallest one. So the smallest one would be 2x. Since it's a positive 2x, I'm going to subtract 2x right here, and I'm going to subtract 2x right here and draw my line. From left to right, I'm going to write now what I have left. So 7x minus 2x is 5x plus 3 equal sign. Mark out those two x's and bring down 23. And now we're at a two-step equation like we did last week. So I go where my x is. It's on the left. The constant term is a 3. So subtract 3. And 5x equals 20. Divide by 5. X equals 4. Questions about that? Okay, that's kind of your basic standard problem. But then there's all different kinds of things that kind of make it a little different. This next one, the 14 plus 3a equals negative 2a minus 1, is kind of a standard problem. Would anybody like to try to do it? Okay, Trayton, out of your 3a and negative 2a, which is the smallest? Okay, so how can I make negative 2a go away? Yeah, so you add 2a here and here. And now, Trayton, what do I have left from left to right? (14 plus 5a equals negative 1). Okay, and now what do I do to get my a alone? Subtract 14. 5a equals negative 15. And then finally, what do I do? Yep, divide by 5. A equals negative 3. Good. Questions about that? Okay. 5x plus 12 equals 2x. Who wants to try this? Tori, what's my smaller coefficient? 2x. This is one that people they don't feel real comfortable with. So, Tori, we're going to go with the 2x. How do I make the 2x go away? Yep, so we're going to do that. We're going to subtract 2x. I hope I don't run out of room here. From left to right, what do I have, Tori? 3x plus 12 equals, and if that all cancels out over there on the right, what do you think I should put? 0. That's where kids say, something's wrong. But it's not. It's okay. Now, Tori, what would be my next step? Subtract 12. And what would I bring below the line? 3x equals negative 12. And now divide by 3. And I'm going to put over here x equals what? Negative 4. Okay, very good. That was a good one. I'm going to wait a minute here and move the screen up a little bit. Is everybody done writing the blue or not? Okay. Let me move this up just a little bit. All right, the one over here on the right, 13 minus 8p equals 2p minus 7. So who wants to try this one that hasn't gotten a ticket yet? Somebody new. CC, what's the smallest coefficient? I've got negative 8p and 2p. The smallest is negative 8. Okay, so how would I make negative 8 go away? What's the opposite of add 8p? Okay, so from left to right, what would I have under the line? 13. Those cancel out. Good. 10p minus 7. Okay, now I need to get the p alone. So what would I do next, Cece? Nope. 10p minus 7. I'm going to leave the 10 with the p for a minute, but I got to take care of the minus 7. Add 7. So under my line from left to right, what will I put? 20 equals 10p. And then how do you solve for p? Divide by 10 on each side. Those cancel out, so my p will equal 2. Okay, so what do you think so far? Not bad. Okay, I have to show you this one. You may not need it today, but you definitely will need it tomorrow. It's something new that we're going to do. We'll do it in Algebra 1. And most people don't like fractions, right? Okay. So what we're going to do with this, it's called kill the fraction. Okay. It's not as violent as it sounds, but we're going to get rid of those fractions. And here's what you do. You take this whole equation and you multiply every term in it by the least common denominator of 4 and 3. And by multiplying every term by that, it makes the fractions go away, thus killing the fraction. So if I have 4 and 3, what would be my least common multiple or least common denominator, Dakota?
12.
12. So here's what you do. You take every part of this problem and multiply it by 12. You're not going to have a whole lot of these, so I'm going to insist that you do this, especially the fraction terms. Maybe not necessarily the whole numbers, but I'm going to have you take 12 times negative 1/4 off to the side. Because we're going to, basically you're taking, not really distributive property, but it's very similar. The reason this works, because the 12 that we're multiplying is really 12 over 1. And the 4 and the 12 cancel and become a 1 and a 3. So when I finish multiplying this off, it becomes negative 3 over 1, which is really what? Negative 3. So this first term is negative 3, and there's an x with it because the x was right there and it's going to stay. I keep going and take 12 times the positive 6. So what's 12 times 6, Dakota?
84.
No, that's 12 times 7.
72.
72. Okay, bring down my equal sign. Now when I take 12 times that 2/3 x, I'm going to ask that you bring it off to the side. Remember that your 12 is over 1. So by killing the fraction, it cancels out that 3. The 3 becomes a 1. What will the 12 become? 4. And remember, there's still a 2 on the top, so when I multiply straight across, I get 8 over 1. There's still an x there, which is really what? 8x is what we're going to write in our problem. And then probably the worst part is this 12 times 28. What is it? 336. Good deal. 336, she says. Okay, we have successfully killed the fraction. Not saying there won't be a fraction in your answer. Sometimes you can't help that. But right now, we don't have a fraction to deal with, and we won't probably till the end if there's going to be one. So Dakota, I'm going to have you finish this one off. You kind of started it for us with at least common multiple. What's the smallest of our two variable coefficients? Okay, how do we make negative 3x go away?
Add 3x.
So add 3x.
Add 3x.
Good. And when I bring my line, what comes down left to right?
72 equals 11x plus 36.
72 equals 11x plus 336. Those canceled out. Now what?
Subtract 336.
Subtract my 336. Okay, so did you happen to check out what this is going to be? It's going to definitely be negative. So we would need to... It's going to subtract, so it's going to be 2 something. I'm thinking 2... Is it 244?
I don't know. I'm not sure.
I'm thinking 264. I'm gonna go with that. Are you sure? Let's do this. Let's do 336 minus 72, and that'll settle it, okay? So 6, there's 4. And then there's 6.
You're right.
264, okay. But thanks for checking. Doesn't mean that I was always right. All right, divide. Now what, Dakota?
You divide 11x on each side.
Divide by 11. And negative divided by a positive. Negative, and then 264 divided by 11. Let's see, that's going to be a 22.
24.
Yep, 24. Negative 24. So we didn't even have to end up with a fraction. Yes, it's a little work to kill the fraction, but I think it's much better off than trying to add and subtract fractions and things like that. So you will get a couple of these tomorrow. I don't think you'll have any today. So you might need to refer back to this problem when you have that one.